All right, folks, we're going to get started. Show me you're ready. So what did you notice about the rational function? Anybody else notice the 2x minus 7s? What should we do with those?
Cancel.
We should cancel them. So when you have factors cancel in a rational function and then you want to graph it, that factor is still a part of the original function, and 7 would still make your original function have a denominator of 0, which is not okay. So you're going to have this value of 7 that's undefined on your graph, but it doesn't make an asymptote because of the canceling out. So it doesn't make an asymptote, but it is undefined, and so what it makes is a hole. It makes a hole on your graph. When you look at a graph that has a hole on the TI calculator or on Desmos, it doesn't look like much at all because that hole has an infinitely small size, so you can't even see that there's a hole there. But when we graph by hand, we actually do graph the hole like as kind of an empty point, just to indicate that we know that that value is not defined. Okay. Most of this stuff is the same stuff that we did last class, but there's something added, which is the hole. So the x value of the hole is going to be the 0 of the canceled factor. So here in this one, we would do x minus 7 equals 0, and we would do x equals 7. So from the example here, x minus 7 equals 0, x equals 7. So that would be the x value at the hole. But the hole has two coordinates, an x-coordinate and a y-coordinate. So to find the y-coordinate, you put 7 into the reduced function. The reduced function is what's left after you cancel this out. So 7 plus 1 over 7 plus 9 gives me 8 over 16, which is 1/2. Okay, the vertical asymptote comes from the remaining factor in the denominator. So the remaining factor is x plus 9. And so for the vertical asymptote, I would do x plus 9 equals 0, which gives me x equals negative 9. Remember last class we said to find the x-intercept, you make the y 0. But if the y 0, really it's just the top of the fraction that's 0, because 0 over any number is 0. So you find the 0 of the remaining factor in the numerator. So you would do x plus 1 equals 0 and x equals negative 1. And then to find the y-intercept, you substitute 0 for the x's. And so 0 plus 1 over 0 plus 9 gives you y equals 1/9. The end behavior asymptote is also called the horizontal asymptote. I think today we might actually look at slant asymptote, so horizontal or slant asymptote. A slant asymptote is like a diagonal line instead of a horizontal line. Okay? But your end behavior asymptote can be your horizontal asymptote or your slant asymptote, and remember that depends on if you have a bigger exponent on the top or on the bottom, or if your exponents are equal. It's a lot to keep track of. Okay, what I want you to do first is factor your numerator and your denominator. Remember, you're going to find numbers that multiply to negative 20 and add to negative 1. Factoring is essential in this unit. All right, Aaliyah, can you factor the numerator for us? But what did you write for your actual factors? Beautiful. And then PJ, how about the denominator?
X plus 4 and x plus 2.
Okay. So we factor the numerator and denominator. If you're having trouble factoring, feel free to come by SS7 and just say I want some help with factoring because it's important for this. So we need to cancel this one out. And then you write your reduced function. That's the one after you've canceled it out. It should start with y equals or f of x equals. And then what's left? All right. The whole is created by the canceled out factor. So I'm going to set x plus 4 equal to what? 0. Because I want to know what number would make that x plus 4 0. That's the number that's going to create the whole. So I'll just do that work right here because I have some space. X plus 4 equals 0. And I get x equals negative 4. And so negative 4 is the x coordinate of the whole. We haven't talked yet about how to find the y coordinate of the whole. I think we did actually, but just briefly. You're going to take this negative 4 and you're going to substitute it into the reduced function. So negative 4 becomes the x value here. So the work is going to be negative 4 minus 5 over negative 4 plus 1. Negative 4 minus 5 over negative 4 plus 1. I substituted negative 4 into the reduced function. It gives me negative 9 over negative 3, which is just 3. Often the y coordinate of your whole is going to be a fraction. It's just because things work out in a messy way sometimes. But this time it's just 3. So that's my whole. I think I'm going to use the space over here on the right for my asymptotes. Your vertical asymptote is going to be what makes this denominator equal 0. So x plus 1 equals 0. And subtract the 1. X equals negative 1. You can't just write negative 1 because that's not an equation. You have to write the whole equation of the asymptote, and it's going to be x equals negative 1. All right. Horizontal asymptote depends on the exponents. So if you look here, this is x to the 1 and this is x to the 1. They have the same exponent. So then the asymptote comes from the coefficients. There's no coefficient here or here, so you can give them both 1, and 1 over 1 gives you what? 1. The horizontal asymptote is one of the trickier parts because it's different depending on the exponents of your numerator and denominator. But when they both have the same exponent, x to the 1, x to the 1, you take the coefficients of your leading terms. And there was no number here, so I know that's 1x. So it's 1 over 1. So we had two different ones here. We put in the exponents of 1 and we put in the coefficients of 1 to determine the horizontal asymptote at y equals 1. Good morning. All right, intercepts. To find your x-intercept, you make the y 0. And so I have 0 equals this whole fraction. But remember that to make your life easier, when a fraction equals 0, it's really just the top that equals 0. 0 over any number is 0. So you can set 0 equal to x minus 5. And then solve that, and you should get 5 equals x. For the y-intercept, you're going to make the x 0. And I'll pause for a moment before we do end behavior. As x goes to infinity, y, oops, that's not infinity, y goes to 1. And as x goes to negative infinity, y goes to 1. So we never graphed this one. If I were doing this problem on a test, I would probably graph it on my calculator to make sure I did it right. Remember that when we graph on these calculators, we need to put parentheses around the numerator and the denominator. Okay, so this time it was factored for you, and you canceled out the x minus 2. And then to create the whole, you set which factor equal to 0? The x minus 2. So for the whole, and like there's not a whole lot of space, so I'm just kind of using all the space I have. I did x minus 2 equals 0. And then that got me x equals 2. And that's the x coordinate of my whole. Let me write my reduced function here. X plus 6 over x minus 4. All right, what do I do with the 2 to find the y value? So you're going to substitute 2 for the x. So then I have 2 plus 6 over 2 minus 4. 8 over negative 2, which gives me negative 4. Did you guys get negative 4? Okay. So my whole is at 2, negative 4. And we're going to graph that. And some of you have graphed on your calculator. First of all, if you graph the reduced function, the whole won't show up at all because you canceled it out. If you graph the original function with an extra set of parentheses to keep your numerator and denominator together, you still won't see the whole, but it will show up as undefined in your table of values. But your whole is at positive 2, negative 4, and you're going to create a point that's empty, like that. That's your whole. All right, vertical asymptote. Vertical asymptote also comes from your denominator, but it's the one that didn't cancel out. So what factor do we set equal to 0 for the vertical asymptote? Jennifer, what did you do for this one? So for the vertical asymptote, she set x minus 4 equal to 0, and you got x equals, good. All right, take a look at your paper and make sure you have x equals 4. If you just have 4, you didn't write an equation. You need to write x equals 4. All right, horizontal asymptote is a tricky one. First of all, you have to look at the biggest exponent. So this has an exponent of 1, and this has an exponent of 1. When the exponents are the same, then you're going to take the coefficients. So, just like in the last problem, this has a coefficient of 1, and this has a coefficient of 1. And so it's going to be y equals 1 over 1, which is 1. So let's graph these at x equals 4, 1, 2, 3, 4. And y equals 1. I'm going to skip over domain and range and do those last. Let's do our intercepts. So we need to use some space for these intercepts. I'm going to use a space below the graph. All right. To find your x-intercept, you make y 0. So here's my y. And if I have a fraction that equals 0, just the top equals 0, so it's going to be x plus 6. And I subtract the 6. Negative 6 equals x. So my x-intercept, negative 6 is the x, and I put 0 for the y, that goes there. What did you guys get for a y-intercept? I think that's what I got. Yeah, let's look. So for y-intercept, instead of f of x, I can just write y. They're the same thing. And then I'm going to put 0 plus 6, 0 minus 4, and 6 over negative 4. You could have negative 3/2 if you like fractions, or you could have negative 1.5. All right, we're going to graph those, and those are going to be solid points, not empty points.
Yeah, this one.
All right, everything I have so far is on the left. One more time. So when you graph it and you use the table of values, you can find some more points. And so I found 6, 6, and 9, 3. And I put those on my graph. And then on this side, make sure you go through your points and your hole. I like to go like that so that you can see it's still empty in your hole. Like that. End behavior is going to be the same as in the last lesson. Domain and range has a little twist because we have to leave out the hole and the asymptote. So we're going to do that. For end behavior, as x goes to infinity, y goes to what number? 1, yep, it's your asymptote. As x goes to negative infinity, y goes to still 1, right? Still 1. So your horizontal asymptote is going to determine your end behavior on both sides. All right, domain, we got to leave out the hole and the asymptote. So it's going to start over here on the left at negative infinity, and it's going to go all the way up until we get to this hole that has an x value of 2. Then we'll do the piece between 2 and 4, where the asymptote is, and then we'll do the piece from 4 to infinity. So it has 3 pieces to it. Start at negative infinity, and then go up to the hole, which is an x value of 2. Then 2 to 4, your asymptote. And then from 4 to positive infinity. Okay, so you had to leave out the hole, and you had to leave out the asymptote. Try your range. In the range, again, you're going to leave out the hole. Okay, for your range, you should have started at negative infinity. And then what's the y value of the hole? Negative 4. So you go negative infinity to negative 4. Then you start again at negative 4, and you go up until your asymptote, which is at 1. And then 1 to infinity. Okay, when you're done with that, I need you to factor example 3, and then we'll work through it together. Okay, the top is difference of what? Difference of squares. Good, and the square root of 1 is 1. So it should be x minus 1 times what? X plus 1. Because of the difference of squares. All right, on the bottom, the numbers that multiply to negative 3 and add to negative 2 are negative 3 and what? Multiplies to negative 3, adds, yeah, negative 3 and 1. So I'm going to put negative 3 and positive 1. These will cancel. And then this is my reduced function. You can't see it. Better? Okay. The whole comes from which factor? Yes, the one that canceled out. And because it's in the denominator also, so that's good. All right, so for the whole, I'm gonna start with x plus 1 equals 0. And get x equals -1 and put that there, comma. What do I do with the -1 to find the y value? Very good. Substitute it for these x's, and then we'll find this. It might be a fraction, it might be a number, we'll see. All right, so we have -1 minus 1, -1 minus 3, -2 over -4. What does that simplify to? So negative over negative is what? Positive. And I could write it as positive 0.5 or positive 1/2, up to you. I think decimals are easier to graph, but that's up to you. All right, to find my vertical asymptote, I need to set which factor equal to 0? Yes, the one that's remaining in the denominator, which is the x minus 3. So vertical asymptote, x minus 3 equals 0, x equals 3. So far, everything that we've done has had the same horizontal asymptote. That's not going to always be true. But in this case here, they had the same degree on the top and the bottom here, same degree, and even reduced same degree. The coefficients are still just 1 and 1, and so that's why we still have a horizontal asymptote of y equals 1. It's not always going to be true, but it is today. We'll do domain and range last, but I'm going to graph those asymptotes in the whole. So -1 and 0.5, there's the whole. And then x equals 3. And y equals 1. Okay, x-intercepts. You guys ready? All right, for the x-intercept, we make the y 0. So 0 equals this whole fraction, but really 0 just equals what part of the fraction? If a fraction equals 0, is the 0 on the top or on the bottom? It's on the top. So we just need to write 0 equals x minus 1. All right, so we have 1, and then we put 0 for the y. That's our x-intercept. For our y-intercepts, we make x 0. So I put 0 for both the x's in my simplified fraction up here. I got -1 over -3. Negative over negative is what? Positive. So you could have 1/3 or 0.3. Okay, so I'm going to graph those. 1, 0. Oh, and 0, 1/3 is super hard to graph right there. All right, let's put this in the calculator so we can get some numbers to graph over here on the right side. So remember when you do it to put parentheses around the numerator and around the denominator, okay? Press the y equals button. If you don't know where the y equals button or you're having any trouble with graphing this on the calculator, please ask a neighbor to help you. The values I got from the calculator were 4, 3, and 5, 2, so I'm going to graph those there, and then sketch your branches in. All right, so you should have sketched this in already. Let's do the end behavior. It's always going to be straightforward. As x goes to infinity, what does y go to? 1. Good. Because it's your horizontal asymptote. Always going to be your horizontal asymptote if you have one. Oops, I'm frozen. All right. Try to work ahead of me on domain and radius. And then my domain goes negative infinity until the whole, so that would be -1. And then the whole to the asymptote, so -1 to 3. And then from the asymptote to infinity. And then your range is going to be negative infinity up to the whole. And the whole was at 0.5. And then you've got this little tiny piece between the whole and the asymptote. 0.5 to 1. And then from the asymptote up to infinity. All right. Make sure you're caught up. I can answer questions during your brain break